Okay, I'm recording from this point forward, but I will go back and I'll record the PowerPoints.
No problem. I just wanted to make sure because this sounds very important.
Yeah, and I had every intention of doing that because I did not do that, but I do have everything in the PowerPoints, and I'll just go back and do a record over for those. And I might have to, I need to go to another file to find the Word document that I did for the findings, simply because I'm on 2 different computers, and my work computer is not compatible with my other one. So give me just a second and let me pull up that Word document. And I'll also be sure and give y'all a copy of this Word document where I did the analysis, the output analysis. All right, so let me go to here. Oh, I can't believe I did not turn that on to record. Thank you for pointing that out, and I will make sure I correct that. We'll have multiple regression. We'll have regression recorded, but the correlation coefficient, I'll have to go back and re-record those.
Hey, Dr. Judd.
Yes.
This is Erica. You froze on my end, and I don't know if you're frozen on anyone else's end, but I'm probably going to log out and then log back in. It could be my connection.
Am I frozen for anybody else?
Your face is frozen, but you're talking. Like I can hear you normally.
My computer is acting up. Zoom. Everybody still there?
Yes.
Can y'all see me?
Okay, you're not frozen anymore.
Yeah, that worked.
Good. I don't know why I did that. Okay, I'm trying to share.
Oh, there she is. Okay, I see. I was about to say she's still frozen, but that's the old photo. Okay.
Okay, let me go to participants. Oh no, but I'm not the host anymore. Oh, there I am. Okay. Share screen. So now I want to find, okay. All right. Now, can y'all see my screen? Okay. Whew, I'm sorry about that. Okay. This is the output that you get when you run the linear regression. Okay. It was too much just to put in the PowerPoint, so I've put it on a Word document. And when you get your output, there's 3 tables. You get a lot of tables with your output, okay? There's 3 tables that you're really interested in for your linear regression. It's the model summary, your Anova summary, and your table of coefficients, okay? So this first one, it just tells you what you have there. Nothing there. There's your syntax. If you have any errors, it'll show up in there, but okay. Your correlation, see, here is exactly what we ran with our correlation coefficient. So you may not have to do the correlation coefficient separately if you're doing multiple regression or linear regression, because it gives you those there. But that's exactly what we got whenever we ran our correlation coefficient. Okay, so linear regression also runs that for you. Okay, there's our descriptive statistics, and again, it's the same that we got before. Variables entered and removed, you don't have to worry about that. That's only if you do a stepwise or if you're doing a multiple regression. So you don't have to worry about that particular one. The model summary, we're interested in what's right here because we're going to need this to help build our equation, okay? So the standard error of the estimate, which is right here, gives you a measure of dispersion for your prediction equation. This is important for your prediction equation. When the prediction equation is used, 68% of the data will fall within one standard error of the estimate predicted value, and just over 95% will fall within 2 standard errors. This will make a little bit more sense as we move down and go through this. So in our example, our estimated severity of injury will be within 4.37 points of being correct 95% of the time, okay? This is going to make sense as we get down to the actual equation. So this, you're going to come back to this. This is going to be important. And this standard error of the estimate right here, and then this R that you're going to report are what's important, or your R squared is what you report. So that's what's important. Your Anova table, okay? Your Anova table gives you your significance, which we got the same significance when we did our correlation coefficient. It gives us our F right there, and it gives us our degrees of freedom. So this is important here for the significance most of anything, because when you run your regression, this tells you if you have a significant regression or not. So we have the value of 0.01, which is less than 0.05, which is our threshold. So we do have a significant linear regression. Then the other one that you're interested in is your coefficients. This is the other table that you're interested in, and this gives you your coefficients. And you have a significance level of here of 0.000. And this is where your actual prediction equation is going to be found, okay? So the values of both A and B, which is the dependent and the independent variables, are right here in this B column. You see the B column right here, okay? The first value, the 6.847, which is labeled as the constant, is considered the value of A, which is going to be the dependent variable. Our independent variable, remember, is strength training. Our dependent variable is our risk, severity of injury risk score, okay? So the second value of the negative 0.125 is the value of the independent variable. So our prediction equation is severity of injury 6.847, which will really be minus the point, because we have a negative 0.125. So it's plus minus, but don't worry about the plus in there. So it's 6.8475 minus 0.125 hours of training. And then you would times that by hours per week. That's how you're going to get your prediction equation. So an athlete who trains 1 more hour per week than another athlete reduces his severity of injury risk by negative 0.125. Okay, an athlete who engages in 10 hours of strength training each week is at a level of severity of risk of 5.597. And why we say that is because we have the 6.847 minus 0.125 times 10 hours per week, and that gives us the 5.597. Okay, and then we have, whereas an athlete who engages in 20 hours of strength training per week reduces his severity of injury of risk to 4.347. And we use that same formula, 6.847 minus the negative 0.125 times the 20 hours per week, and that gives us the 4.347 on our severity risk. That's your prediction equation. Okay, so this right here gives you that prediction equation. Clear as mud?
You're gonna update. You're gonna have this Word document on.
Yes.
Okay. Thank you.
Yes, I will. I'll add it. So you'll have the PowerPoint, and then you'll have the Word document where I explained all this out. Okay. And then if we actually go all the way down here, we can draw our conclusion. And for those of you for multicollinearity, it also gives you the collinearity diagnostics if you're doing a regression. But so drawing our conclusions, this is what we would write. Okay. A simple linear regression was calculated to predict athletes' risk of severity injury level based on the number of hours spent strength training. A significant regression equation was found. We report our F, which is from our Anova table, our degrees of freedom, which is from our Anova table. So we have 1 and 28 degrees of freedom equals 7.346, which is our F. And the p-value is less than 0.05, because remember it was 0.01, with an R squared of 0.210. Okay, that comes into, that's found in our model summary. There's our R squared, 0.210. That has to be reported when you report your multiple regression or your linear regression. Athlete's predicted level of injury severity is equal to 6.847, technically minus, I didn't have to put the plus there, I could have just put minus 0.125 times number of hours. Severity when strength training is measured in hours. Okay. Athlete's average risk severity level decreased negative 0.125 level for each hour of strength training they engage in per week. That's what we were able to determine from this linear regression. So for every hour of strength training, they can reduce the severity level, the risk of a severe injury by 0.125. So we have that inverse relationship. Make sense? Maybe not. It does when you sit down and you actually, when you go through each one and you plug that into that formula, then it does for me. Then it's like, okay, I get it. It makes sense because I go back and I determine which variables going which way and how that works. But this is how you actually get that correlation coefficient. This is actually how you get your prediction equation. And so then you can predict that every time an athlete engages in 1 hour of strength training, they're going to reduce their risk for severe injury by that 0.125. Now, we talked about effect size when we also talked about the hypothesis, and we have to think about effect size. If I'm an athletic trainer, is that going to be enough of an effect that I want my athletes to do 40 hours worth of strength training a week, or am I going to hit a plateau or something like that? So when I think about it conceptually, I may want to look at other variables that can also reduce the risk of severe injury. And then I can actually collect data on those. And then I can do a multiple regression, to determine which of those variables are impacting that reduction in risk of injury the most. So I may want to, if I'm an athletic trainer, I may not just want to concentrate on strength training. I may want to add those other variables in. And that's what we'll do multiple regression next week, but that's what multiple regression will tell us, is it tells us how much each of the different variables are contributing to that equation. Does that make sense? Okay. So let me do this next step. Okay, and I will upload that Word document. So the other thing you do is you graph it. And when you graph it, it'll give you, when you graph it, it will give you the linear equation or the line, okay? So you're going to go, when you graph it, you're going to go to graphs. You're going to go to legacy dialog. When legacy dialog comes up, this drop-down menu comes up. You're going to select scatter dot. That's what you want to graph for your regression. When you do that, you hit OK. This one right here comes up. You want simple scatter. So you hit simple scatter and then you hit define. Okay. Then this right here comes up. And you've got your y-axis and your x-axis, all right? Your y-axis is going to be what? your dependent variable, your x-axis is going to be your independent variable, okay? You're going to hit OK, and you're going to get this. So here's my severity of injuries from 1 to 8, and here's the strength training per week. Now, just kind of looking at this, I can't really tell, can I? It's kind of all scattered out right there. So what you can do is you go to chart editor. You click on, what you do is you click on this. When you click on this chart, the chart editor comes up. And when you click on the chart editor, you go to this one right here. And we'll walk through it because I actually forget what it says. I meant to label it. I think it says Fitline, but you go to, you click on this one right here. And when you click on that, you're going to get the line. So what can we see? We can see that the risk of severe injury decreases as what? Strength training increases. So we have a negative. And look what happens right here. Here's your formula. Y equals 6.85 minus 0.13, which they just, the program rounded up right there, times X, which is the number of hours. It gives you your formula right there. So you can pull your formula out of your tables, and then this right here gives you your formula also. So let's just walk through that on SPSS. Let me find my. Okay, let's try this again. Where did it go? All right, now it's not wanting to come up.
Dr. Judd,
Yes.
Terry had to disconnect and tried to reconnect, so I was going to see if she might be trying to get back in.
She is not there.
Okay.
Yeah, I don't see her. Now, okay, now my SPSS is back. Let me try. Okay. So now we're going to, can y'all see my SPSS? So now, okay. So now we're going to do the regression. So we're going to go to analyze. All right. Then we're going to go to regression. I can't get this out of the way. Oh, we were going to do graphs. We already did that, didn't we? Okay, so we're going to go to graphs. We're going to go to legacy dialogues. All right. We're going to go down here. We're going to go to scatter dot. When we click on that, this comes up. We go to simple scatter. We define. Okay. So we're going to have number of hours, which is going to be my independent variable, severity of injuries, which is going to be my dependent variable. And when I click on that, this right here comes up. Okay. Then I want to get to the chart editor. So I double click this.
Dr. Judd, you need to do
Editor comes up.
You need to do a new screen share because it pops up in a separate window.
Okay. So can you see that? Can you see the graph right there?
No, it when you hit share screen, sometimes there's an option when you're already sharing to do a new share. So you can click new share, and then you should be able to show the new graph that popped up.
Okay. Oh, there it is for new share. Okay, can you see the graph now?
Yes.
Okay, so would I click the new share before or after I do the next one?
So the new share option gives you, it kind of streamlines what you're doing in Zoom. So whenever you're showing like the initial steps in SPSS, it can show everything. And then whenever it pops up in a new window, like a chart or the descriptives or something, that's when you can hit the new share button and it should just pop up the new screen for you.
Okay, we will try that because now you've got this graph right here. So if you double click on it, then you're going to get a new graph. Can you see that? Okay, thanks for showing me that. I learned something. And
Me too.
I did, yeah, that's great. So when you double click on it, you get this, and right here, no, okay, it's gonna be this first one. It says add Fitline at total. See that right there? When you highlight that, it says add Fitline at total. So when you click on that, it'll come up and it looks kind of funky right there. But then when you click it off, it shows up on your graph. So that's how you do that. Again, it gives you it gives you your actual equation right there, which means that you can plug into this equation any number of hours where this X is, and you can do that equation, and that will tell you how much that risk score goes down with each one. So what do y'all think?
I was just gonna say that I didn't have to like go back and reset to the variable screen. I just kept plugging away at all of the little things that you were showing us, and I didn't have to go back and reset. So now all of the information is on one document.
Yes, yes.
That was neat. I learned something.
Yeah, yes, exactly. You can do it that way. So like I said, as you start learning SPSS, you're going to learn tricks in there. And it's kind of like any technology. There's multiple ways to get to the same end. Everybody might take a different road. So as we start sharing, oh, look at, you can do it this way or you can do it that way. And it's whatever you get comfortable with doing. Like I said, I do some extra things, but it's just because that's what I'm comfortable with doing. Because when I get ready to write my results, I know where I want things to be at. So just get into SPSS and play with it. I know y'all don't think that's playing, but it really is. It really is a lot of fun just to play with it. I thought about, and I have no idea what y'all's schedules are like, but I can actually send out like a sample data set, and y'all can go through the regression if you want to, and then I can give you some feedback on it. I don't know if you want activities like that or not, or if you just want to stick with it.
Yes, please. Sorry, Dr. Judd. Yes, please.
Okay.
Yep.
And so I'll do that. And that way you can practice it and you can get some feedback. And it's not just all time for, homework number 2 or whatever. So yeah, so I can do that, because really and truly you need to be in SPSS and you need to be playing with it. That's the only way you're going to learn it. And you're going to get things, you're going to find out as you're running things, you're going to get things that make no sense. And it's because you probably have run the wrong statistic test for the wrong variables. But that's how you learn. That's how you learn to do it. So you can't destroy SPSS. Oh, and there was one thing I did remember I wanted to tell y'all last week, and I thought about it this week. When you do your dissertation and you have your data and you have all your wonderful data, put that into a file, put your raw data in a file and put it on an external drive, put it in the cloud, put it somewhere. Don't mess with it again. Copy it into one that you're going to be using. Okay, always keep your raw data pure. So you'll have two files, okay? So you're gonna have your raw data that's pure, and then you're gonna have your SPSS file that you're gonna be working on. Because as you're running these statistics, you may be doing some recoding in there. You may be creating new variables by taking a ratio level variable, bringing it down to an ordinal level variable as you're doing all of that. If you mess up your original data, you're screwed. That's just the bottom line. So I can't say it enough. Always keep your original data, one file of your original data somewhere away where you can always go back to it and you're not going to use it. Have a copy of it that you're going to be working with and doing all of your statistics with. Because again, if you ever mess that up, you may not be able to get your raw data back. So you always keep that separate. That's what I meant to tell you. Because as you're going through and you're practicing and you're doing all of these things, you're going to mess them up. You're going to mess some things up. And so it's nice to have a clean set of data, and you can always just copy it, duplicate it, always save one file that you don't do anything on. It's just your raw data. Listen to me. I know. Been down the road. You want to do that. And I thought about that this week. I thought that's what I wanted to be sure and tell them, because as you're doing things and messing with your variables, and like I said, you may be recoding some of them, you may be changing the levels on them, you may be creating new variables out of variables you have. So you're going to be messing up your data as you're doing it, and you want to keep that raw data pure. Okay. So correlation coefficient and regression, simple regression. You did it tonight. I will in the morning, I'll grab another couple of variables, data sets, and send them to you. And if you want to practice that and go through it and write it up, I'll create a folder or something where you can pop it in and I can give you some feedback on it, okay? So if you just want to play with it, but know that you're doing it correctly or interpreting it correctly, then I can get you some feedback on that. Other questions?
Thank you, Dr. Judd.
I will, I can't believe I did not record the correlation coefficient part, but I promise I will go back and go over the, and record the PowerPoint for that. The PowerPoint slides are up there. The example articles are in D2L. I will add the interpretation for the regression, the Word document. I will add that in there because I actually just finished that up right before we started class. So I will add that into D2L. It's all under week 4. And then I put it under week 4. And then I also duplicate it into the PowerPoint folder also. So you can find it multiple places. And then I'll record the PowerPoint and put it up there. So you'll have everything we've gone over tonight. You'll have it in hard copy too, okay?
Okay.
Other questions? Okay, it just builds from here. Honestly, there's really not anything just hugely complicated as you build from here. You've got descriptive statistics. We've talked about that. Your mean, your median, your mode, your range, your dispersions, all of that. We've got correlation. You look at correlation between your variables. We've got regression. We're going to go into multiple regression next week. There's one week that we'll do profile analysis. I don't think he had anything built in here where you would do chi-square. Have y'all done any chi-square or anything like that with nominal variables? I'm going to build some of that in here too, because a lot of what we do in social behavioral sciences is really, it's not all scale. There's a lot of nominal level variables that we do. And so there's different non-parametric tests that you do for those. But they all have some of the foundation. The foundation for them all is pretty much the same. Okay. So as you're learning and going along, you're going to be able to say, oh, well, I'll do that for this one and I'll do that for this one. And you're going to learn to interpret them that way. All right, y'all are on your way. Anything else? I will do my best to get the homework graded by this weekend. I'll do my best to do that. Historically, I'm a slow grader, and that's because I take a lot of time and make sure that you get good feedback. But that's my goal every semester, is to get y'all stuff back as quickly as possible. Because if you don't get the feedback, you don't know what you need to adjust or do the next time. So I'll do my best to get that done by this weekend and get them back to y'all, okay? Anything else?
I don't know if this is inappropriate or not, but I'm digging your tattoos.
Oh, thank you. My back.
I was looking at that too. I was like, oh my God, look at Dr. J.
I was about to say, I usually can peg people, and I did not expect that.
Oh, Harley Rider.
Nice.
Actually, my husband and I were founding members of the Bikers Against Child Abuse chapter in Sherman. We rode with them for 5 years across the state of Texas. I've ridden with Banditos. I've been to Banditos clubhouses. We kind of rode on the edge there. That's if y'all work with kids, Bikers Against Child Abuse is an amazing organization. You get a lot of good convictions because the kids will stand up in court. Our president, he was a former 1%er. He was like 6'3" or 4. He had the gauges. He was tattooed everywhere. And you walk him into a courtroom, and those kids, they feel very empowered when they got him by them. So, I'm kind of an enigma there, but just be who you are. Until I got tenure, I always kept them covered at the university. But once I got tenured, I was like, forget it. Let's go. Yeah. All right. Okay. I'll get the rest of this put up and get your stuff graded, get it back to you. If y'all have any questions, let me know. Otherwise, have an amazing week. Bye.
Thank you.